So let's go back and just review how we can use these Laplace transforms to solve. Laplace to solve. So we got here a differential equation. And what we want to do is I want to find the Laplace transform for each part of this. And notice we've got these initial conditions. So we've got y of 0 is 0, y prime is 0 is 0. Now recall that the Laplace transform of y prime, the derivative, first derivative is this, okay? Where this big f of s, that's the Laplace transform of the solution. It's this y of t that we're in search of. Now, the Laplace transform of the second derivative is this. So we remember that. And I've got a little table here of Laplace transforms. Now, what we want to do is we want to go through here on a Laplace transform rampage. And we find the Laplace transform for everything that we can get our hands on. First of all, the y double prime. Here it is. Then the y prime. Here it is. And finally, just the y, well, I'll just write that as the Laplace transform. And then on the other side, e to the 4t. That's this right here. S minus 4. Okay? Now, the thing is, sometimes you'll get something over here. Like here it was easy. We could find the Laplace transform of that e to the 4t. Oftentimes you'll get something that's a little bit messier. Something where it's not so easy to see what the Laplace transform is. Now remember, you have tables, and also there are Laplace transform calculators out there on the internet, particularly at Wolfram Alpha. That's a good one. So you can just calculate the Laplace transform that way. Just put whatever this is, this other side, put that in, and you'll get the Laplace transform. But the important thing is that you see the technique here. Now, I utilize these initial conditions, and when you're using Laplace transforms in this way, you always start off with y of 0 and y prime of 0. In other words, you're not going, if you have y of 3 or something like that, you're going to have to make some adjustments. You're going to have to maybe do some substitutions or work around that. But this way, it's very straightforward, and we implement those. So notice that this and this and this are all going to be 0. And when we clear parentheses and gather like terms, here's what we get. And I factored out the transform of the solution, so f of s. So I put all this together over here, and I get this. And of course, it equals what's on the other side. Now, I'm going to go ahead, in this case, I chose this problem because I could factor it. Okay, so I factored this. And I'm going to solve for f of s. Okay, so I divide, and this is what I get. Okay. Now, I need to find the Laplace transform for this, so what I'm going to do is I'm going to use partial fraction decomposition. So here I go. I set it up. Okay. And, going through the process, I got this. Now, I'm going to, how partial fraction decomposition works. I'm going to let S be 1, and I find that C is 1/3. I let S be 2 and find that B is negative 1/2. I let S be 4 and find that A is 1/6. So we go through all of that, and then we go back to this, and I just say, okay, the Laplace transform of this right here is what we're looking for. That's y of t. Okay, so that's y of t, and then I take in turn the Laplace transform of these. Okay, so here I go. Here's y of t. I've got 1/6 Laplace transform of 1 over s minus 2, negative 1/2, inverse Laplace transform, that is. Inverse Laplace transform of 1 over s minus 2, and 1/3 inverse Laplace transform, 1 over s minus 1. and we get these in turn, each one of these. Now, these differential equations can differ in complexity, and like I say, sometimes you're running into trouble trying to find this Laplace transform. So there's different techniques that you can use, but don't forget, you've got these applications on the internet and you've got these tables. So really utilize those if you need to.